This is the lesson for the second day of Chapter 8, Section 2, titled Multiplying and Factoring, day number 2. So today we're going to be factoring rather than multiplying. So yesterday we used the distributive property to multiply out, and we got an expression like this. So we're kind of working backwards to what we were doing before. And factoring's got a lot of dividing aspects into it too, because that's what we're looking for is factors. Looking for common factors, the GCF in particular. GCF is the greatest common factor, and so that's what I'm looking for in 108 and 60. I see they're even numbers, but also I see that 3 goes into them, because if you add the digits, 1 and 8 make 9, and 3 goes into 9. 6 and 0 make 6, and 3 goes into that. So I can divide these by 6, but I could also divide by 12. So I remember my 12s, and I know that 12 times 9 makes 108, and 12 times 5 makes 60. So I'm going to divide these both by 12, but they also have a common factor of t. So this has 1t, this one has 2t. So I'm going to pull out a t as well as the 12. And so that is the greatest common factor that I'm going to pull on the outside of a parenthesis. And so now I'm going to put parentheses around the width of the problem and do some division. 12 goes into 108 9 times, and then t goes into t squared t times. And so I know this is the right number because 12 times 9 makes 108, t times t makes t squared. So they multiply out to make this value. Well, over here I just do the same thing. 12 into 60 goes 5 times. T goes into t 1 time, so those cancel out. And so you can multiply back to see if you're right. 12t times by 5 makes negative 60t, so that would be it. And so that is the factored form. So there's no more common factors inside the parentheses, so we had pulled out the greatest common factor. Well, look at these numbers. Whenever numbers end in double zeros, 75, like we have here, 25 or 50, I can divide these numbers by 25. So 25 goes into them. And so when I think about that, when I do the division, I'm going to end up thinking of 25, how many quarters make like $3 in this case. And so I'm going to pull out a 25, but I'm also going to pull out D, because each of them has at least one D. And so I can go ahead and pull out 25D and then do the division. 25 into 300. So 25, how many quarters make $3? Well, 4 make $1, so 4 times 3 would be 12. So that'd be 12 quarters make $3. So 25 goes into 312 times. And I still have one D left over because D squared over D just makes 1D. So over here, 25 into $1.75 would end up going 7 times because 7 quarters make $1.75. The D's end up canceling out, so that would be our answer right there. Again, no more common factors inside the parentheses, so I know I am correct. Well, moving back over to this one, I can go ahead and take out the common factor. I see 7 goes into each of these terms, so I'll pull out a 7, but I also can pull out 2 x's, because the one that has the smallest degree monomial here is x squared, and that's what I'm going to end up pulling out, is the smallest degree monomial, is the x's from that, or the variable term from that. So 7x squared goes on the outside, and you do the division. So parentheses around the width of the problem, do the division with each of these terms, and so that's going to make 6x squared. 7 goes into 42 6 times. X to the 4th over x squared just makes x squared. And then here I have 8x, and then over here I have plus 4, and that would be our answer. Oops, except I see one more term. See, I thought I was done, but then I looked inside the parentheses, and I see each of these is even. So let's go ahead and pull off that box and break this down a little more. I see I could pull out a 2 from each of these terms. So if you don't see it all at once, like I didn't see it all at once, I could have pulled out a 14. And so I'll go ahead and divide each of these by 2, pull the 2 on the outside. So I'm going to end up having to multiply this term by 2. So it's going to be 7x squared times by 2. That's what I pulled out. So it makes 14x squared now. And I can now do the division, and I get 3x squared minus 4x plus 2. And now I see no more common factors inside the parentheses, so then I can go ahead and box my answer. So looking at this next one, I see 5 goes into each of these terms. So let's go ahead and divide it by just 5. No x, because the 25 does not have an x. I'll put the 5 on the outside of the parentheses. Left with 2x squared plus 10x minus 5. Now look at these terms. No more common factors. 10 and 5 have a common factor, but None of those, 10 has 2, but 5 does not have the 2, so I cannot take out another factor there. Over here, I could take out a b from each of these terms. Each of them has at least one b, and I can also take out 4, because 4 goes into each of those coefficients. So I'll put the 4b on the outside, do the division. I'm left with b to the third plus 5b squared, and then plus 3. That would be the answer. No more common factors inside the parentheses, so you know you're done. So over here, I divide, and I see that 9 goes into each of these terms, so I'll pull out a 9. But then I also see an h right here, 2 h's, and 4 h's, so I can pull out 1 h on the outside of the parenthesis. Do the division, I'm left with 2h to the third minus 3h, and then plus 2. And that would be our answer. So again, looking inside the parentheses, no more common factors, so I'll go ahead and box that answer. Now let's take a look at the next type of problem we see. So over here we've got a circular hedge surrounds the sculpture on a square base. So the sculpture is right here, and it says that the radius of the hedge is 6x. That's what it shows here. So from this dot right here, from the center of the circle to the curve of the circle is 6x. The side length of the square is 4x. And so since it's a square, all sides are the same. And it says, what is the area of the hedge? So the hedge is just this region without the box. So basically what we want to do is I want to take the circle and I want to subtract the area of the square is what I want to do. So if I look at this way, I'll go ahead and write in the 6x right there for the radius of the circle. The box has, or the square has, 4x by 4x. So when I remember the formula for the area of a circle, it's pi r squared. Area for the square is just going to be base times height, or just base squared, we'll just say. And I can go ahead and find out what the areas are. So area here is pi, and then in place of r, I'm going to put 6x. Now make sure you put that in parentheses since it is the radius, and we are squaring it. And so from there, I can go ahead and take a look at my next part. Now 4x, I can just square that because, again, the 4x and the 4x are the same. So I'll put parentheses around the entire part because 4x is the length. So I have to put parentheses around the 4 and the x. So I do the work here, and I've got, now I have to square both components. So it's 36x squared pi. So you have to square the 6 along with the x. Same thing here, 16x squared. So what they want us to do is write your answer in the factored form. So we're looking at that term. Okay, I'll rewrite it over here. 36, and I'm going to write the x first. 36x squared pi, and then over here minus 16x squared. So what I see from these two terms is a common factor of 4. So I see 4 goes into 36, 4 goes into 8, or the 16. And then I also see an x squared. That's the same as well. So I can pull out that x squared, and what I have left is 9 pi. And then over here, what I have left is minus 4. No more common factors inside the parentheses, so I know I have it factored completely. So you can see that it works because 4x squared times 9 pi just brings us right back to this. And 4x squared times 4 brings us right back to the 16x squared. So the reason why we like to do this is when we see some other problems in the future, like there's a surface area problem we're going to end up seeing where we can go ahead and simplify it into a factored form like this. Simplify it and then factor it, and the problem becomes a whole lot easier to solve if we had to do multiple problems. So we'll see that concept being used later on. Let's say, suppose you are making a giant chocolate chip cookie for a raffle. You roll out a square slab of cookie dough. Okay, square. So it's going to be like this, and then it says, then you use a circular plate that touches the edges of the square. So edges of the square be like here. It would touch here, it would touch here, and it would touch here. And then you go ahead and cut out that section. So the circle is going to end up leaving some parts that aren't going to be used. And so it looks like this inside. So there's the circle, and you see these parts right here, they're not being used. So this is extra stuff, extra cookie dough that we're not going to end up using, at least to make this cookie. And so that's what they're asking for here. They say, what is the area of the extra dough? Now, write your answer in factored form. Okay, so they don't give us any lengths at all. And so what we're going to do is assign a variable. They say this is a square, so I know this length is x and this length is x. And so that would mean that the radius of the circle would be 1/2 x. So you could have used any variable you want. I just chose to use x. X equals just the length of the side of the square. Length of side of square. And so then I can go ahead and set up my formula. So the formula is going to be backwards from what we had done, kind of the opposite of what we did here, because now instead of the circle being bigger, the circle is smaller. So I'm going to subtract the circle from the square. And so I know that this side is x and this side is x, but the circle has a radius of 1/2 x. And so I just plug them into my formulas. Remember, your formula here is base squared, and then over here it's pi r squared. Oops, area equals, so let me get rid of that a. So just pi r squared. And so I go ahead and plug in my numbers. So I have x squared minus pi, but then I have to multiply this by 1/2, and then remember the radius is 1/2 x, so 1/2 squared. So I go ahead and do that work. I'm still left with x squared here minus pi, and then over here it becomes 1/4 x squared. So 1/4 because you have to square 1/2. 1/2 times 1/2 makes 1/4. So they say to factor. Now, one thing about simplified form is typically we don't like the fractions in there, and so you can get rid of that fraction. The way I'm going to get rid of the fraction is like this. I'm going to multiply this by 4. And see, if I multiply by 4, then each term I'm going to end up with a 4x squared here, but this becomes minus just pi x squared. Pi x squared, because the 4 multiplied by the 1/4 cancel each other out to make 1. Everything's being multiplied, so it's just now 1 times pi times x squared. So now I can go ahead and factor out the common factor. So I see that each of these has an x squared. And so when I go ahead and do that, I'll pull out the x squared, and what I'm left with is 4 minus pi. Now, if you had not, and these are units squared, and these are units squared too, I should say. So if you had not pulled out that, or multiplied by 4, here's what we would have had. We still would have had that x squared minus pi, and then let's pull out the 1/4 x squared. And you would have pulled out the x squared just like you had done in the last one. It would be this, x squared, and then you'd have 1 minus 1/4 pi. And that's the same exact answer. So these are the same answers. The only difference is that we don't have the fraction here. And you see how this is more simple because there's less components. It's just 4 minus pi, which is easier to think of than 1 minus 1/4 of pi. And so that's why if we were writing in the simplified form, this is the more appropriate way to do that. Well, let's take a look at the last type of problem that we'll end up seeing here. And what's different about these is that there's more variables involved in the factoring. So you just have more stuff to be concerned with. So we pull out the common factor first. So let's pull out a t. Now there's one s that's in common here, but 4 t's. And so that's what I can pull out from each of the terms. And so let's go ahead and do that. Pull out 2st to the 4th and do the division. See what's left over. 6t, actually just 6. S is canceled, t to the 4th canceled out. So just a 6, and then plus, and then do the division here. I end up with 23s squared, and that's it. Now, you look inside the parentheses, no more common factors. Everything multiplies back out to make the same thing, so I know that's the form they wanted. So I do the same thing here. Looking at these two numbers, I see 9 goes into each of them. And it looks like they each have a c squared. This one has 3, this one has 2. So I pull out 2, and I can pull out d squared also. So 9c squared d squared. We do the division and see what's left. 9 goes into 54. We have 6 times. And I end up having just no c's left over and 1 d. And then over here, I do the division. I have 4 times, and there's 1 c left over, but no d's. Well, I can continue working. You see, these have a common factor of 2 when I look at that. So I could have pulled out an extra 2. So I'll go ahead and do that work. And Let's go ahead and put a fraction bar there, put the 2 underneath, and I end up with 18c squared d squared now when I multiply the 2 and the 9 together. And I'm left just with 3d minus 2c. And so if you don't see the greatest common factor, like I didn't see 18 right away, once you finish doing the division, you still see common factors inside the parentheses. Pull that out. Well, let's take a look at the next one here. We see that there is a common factor of, let's see here, 13, it looks like. Well, but 13 doesn't go into 51. So 3, nope, 3 doesn't go in there either, and 17 is the other factor I see in 51. So I don't see any common numbers in those terms, but I do see some a's. So I see a to the 4th and an a to the 4th over here as well. And so I'll go ahead and pull out that a to the 4th, put that on the outside of a parenthesis, and do the division. So I still have the 26, and I also have an a and a b squared left over. And then over here I have plus 51, and that was it. That's as far as I could go. So I didn't see any common factors in 26 and 51. 2 goes into this number, but does not go into this one. Let's see, 13 goes into this one, but not this one, and 17 and 3 go into this one, but do not have factors of 26. So that's it. That's as far as we go. Here we have a common factor of 11e squared f to the 3rd. So each of them has at least 2 e's. This one has some extra f's. And so here I do the same thing, 11e squared f to the 3rd, and I pull that on the outside of the parenthesis. I do the division, and what I have left is just an e here, no other parts. And so if everything canceled out, it'd be a 1, but in this case, just the e. Here, 11 goes into 132 12 times, and it looks like just an f left over, because the e squared is canceled out, and 1 f left over. And so no more common factors inside the parentheses, so that would do it. Those are the types of problems you'll see on tonight's homework. Good luck.